Hi again. This is the third part installment on the Brownie stoichiometry packet. These are the answers for the table from the last assignment. So those of you that are watching this and staying up with things, you can check your work on this. Wanted to go through it because a lot of people were having difficulty, and maybe by going through this example and completely with you, you'll be able to more easily do the last page. So this reaction was with magnesium and aluminum sulfate. So I wrote them in order as they were presented in the problem. Magnesium, of course, is an element. Aluminum has a +3 charge. Sulfate has a -2, so we have to do the 3-2 switcheroo thing and put the sulfate in parentheses. So aluminum sulfate's a pretty big compound. 2 aluminum atoms, 3 sulfur atoms, and 12 oxygen atoms in one of these. And this is going to be a, hopefully you know, single replacement reaction. And if you look at your sheet, the magnesium is able to bump the aluminum. Aluminum comes out of this reaction and then can be used to make things. So magnesium is a +2. When it forms an ion, it loses 2 electrons. Sulfate's still a -2. So they go together 1 to 1, and then aluminum's just an atom by itself, okay? So when you look at that, you know that there's a 2 here for aluminum, so there has to be a 2 here. There's 3 sulfates, so we're going to need 3 magnesiums, which will make 3 magnesium sulfates. So the mole ratio, how many pieces of each? You need 3 of these, 1 of these, make 3 of these, and 2 of these. Molar mass stuff, I hope you're comfortable with at this point. Just look on the periodic table for the molar mass of magnesium. Aluminum, we have to take aluminums twice, sulfurs 3 times, oxygens 12 times to get 342.2. 1 magnesium, 1 sulfur, and 4 oxygens makes 120.4. And then on the periodic table, it's 26.98 or something. I just rounded it to 27 to make it easy, okay? 3 times 24.3 is 72.9. That's the total mass of magnesium we need, but it's really only 3 atoms, or 3 moles worth of atoms, I should say. 1 of these, so we just transfer that molar mass down, makes 3 magnesium sulfates, so 3 times 1, 20.4 is 361.2. And then 2 times 27, of course, is 54. When you add those up, there's a slight discrepancy, and that's because of my rounding, but there's a slight, you know, a penny or a dime out of $415 is not going to bother most people, okay? So that's just one way to think of it, as a very slight rounding variation. All right, let's get to the problem and see how you did with this. Go to your little chemistry cabinet, and you've got 8.4 grams of magnesium. Question is, how much aluminum sulfate do you need to use it all up? So first thing you're going to do, take the grams that you're given, remember this is our given information, and change them into moles. That means you're going to divide by the molar mass, 24.3. You could stop right there, but you can also keep going. From the balanced equation, we get our little conversion factor. 1 of these goes with 3 of these. And of course that's moles or atoms or molecules, but we're going to leave that out of here just for the sake of space. And then the last thing, it asks for mass again, so I'm going to have to change my ask for substance, which is in the numerator, into grams. So I need grams on top and 1 mole on the bottom. So again, we assume these are moles. 342.2 is on top. And then you can just imagine this problem as being a gigantic fraction. Everything in the numerator gets multiplied together everything in the denominator gets multiplied together, and then you divide them into each other. So this ends up being 2,874.5-ish. I may not have rounded it perfectly. And 72.9 in the bottom. That means I'm going to need 30.94 grams of aluminum sulfate to go with my 8.4 grams of magnesium. Okay. The question here is, how much aluminum should we make? Temptation, you could use either number if you're absolutely confident in your answer from your calculations, but I always go back to the given information. So 8.40 grams of magnesium, and it's the same start, 1 mole per 24.3 grams. This time our ratio is going to be different because we're looking at aluminum. So the asked for substance is aluminum. There's 2 that come out. The given substance is magnesium. There's 3 moles that you need. And then again, it's asking for mass, so we have to change our aluminum moles. If we stopped here, we get moles of aluminum. If we stopped here, we get moles of magnesium. And we need to get to grams. So aluminum is, we just went with 27, right? So 27 grams. Again, imagine this whole thing as one giant fraction. Numerator is going to come out to 453.6. Denominator is still 72.9. This time we're going to have 6.22 grams of aluminum if everything went to 100%, which it never does, okay? But that's okay. So you can do this on your calculators once you get it set up on your paper, but you have to use your parentheses or you're going to get weird numbers. So be sure if you're doing this on your calculator that you lock it up with parentheses before you hit the divide button and hit the parentheses again to get your final answer, okay? The last question here, number 11, asks you what's percent yield. Just went over that. So 5.10 grams is what you made. According to the recipe, you should have made 6.22 grams. Multiply that by 100 and you get 81.99, so we'll just call it 82% yield, which is actually still really high. So again, this is the theoretical yield, okay, and this number is the actual yield according to the problem, okay? So that's page 2. So now it's all nice and neat and tidy. It's exactly the same process here for these problems. So problem 12 is writing the balanced equation. So I'm going to go through that with you. I'm going to make the compound so that you can get this. So aluminum chloride. You know aluminum's a +3, chlorine's always a -1, so I'm going to need 3 chlorides. And sodium carbonate, sodium's a +1, carbonate's a -2. So I'm going to need 2 sodiums with my 1 carbonate. Hope everybody's good with that so far. And then this particular reaction has 2 ionic compounds. This is an anies and an outies. This is a double displacement or a double replacement reaction. So the sodium is able to go with the chloride. The aluminum is able to go with the carbonate. Hopefully all of you know that sodium chloride is soluble in water. And the question is trying to be all mysterious. What's the precipitate? Well, you know, obviously it's not going to be the sodium chloride, so it must be the other one. So sodium's a +1, chloride's a -1, so they're good. Aluminum's a +3, Carbonate's a -2. You need to do the crisscross. Okay, and then of course you're going to need to balance this equation. Right off the bat, you've got 2 aluminums, and you only have 1. That gives me 2 times 3 or 6 chlorides. We've got 1 carbonate. I need, oops, boo-boo. I need 3. So I'm gonna have to have a 3 here. That gives me 3 times 2 or 6 sodiums. How convenient. That means we're gonna make 6 salt units. And this one's understood to be 1, 2, 3, 6, 1. Got to get the equation, the formulas right to get the balanced equation right. All right, so I'm going to leave it to you to find the molar masses and to do the total mass and see if they come out equal to each other, which hopefully they will. And then this is the same process. You're going to write down the given mass. This time it's aluminum chloride. You're going to find its molar mass and put it down here. You're going to find the ratio from the balanced equation. You're going to change the precipitate, which is, I'll just tell you, it's aluminum carbonate. Okay, however many of those, go with however many aluminum chlorides. I'm not balancing this. Oops, I may as well. I did balance it. What am I talking about? 1 of these for every 2 of these. Right, from our equation, and I'll leave it to you to change the moles of aluminum carbonate into grams. Same process. Start with the aluminum chloride and figure out how much sodium carbonate you need. Figure out your percent yield. Tell me what 2 things are conserved in a chemical reaction. Hope that makes sense. Hope you're doing well.